Hello students, I'm coming to you with the next video lecture on Rubin and Babby chapter 12. So let's get started. So we're still on unit 4, which is related to designs for evaluating programs in practice. In the last video, we discussed chapter 11, which is related to causal inference and experimental designs. In this video, we will continue to build on our knowledge of experimental designs by discussing chapter 12, which is related to quasi-experimental designs. We're still in the third phase of the social work research process, which is related to choosing research designs and data collection methods. So I want to put before you once again this whole idea of the relationship between research designs, inference, and causal inference. So just as a reminder, we're still talking about designs that are appropriate for groups of clients. Okay, so as we continue our discussion on experimental and quasi-experimental designs, just keep in mind that these are group-based research designs. So once again, as a reminder, quasi-experimental designs, just like experimental designs, are appropriate for drawing causal inferences. So before we get into the specifics of quasi-experimental research designs, I first want to say a little bit about the feasibility of true experiments in social work agency contexts. So we talked about experimental research designs in the last lecture, and we refer to these kinds of designs as true experiments. And the reason for that is because of a couple of the features that are inherent in an experimental design. One of them is randomization, and the other one is the use of a control group. So these are two key features of an experimental design that makes them what we refer to as true experiments. However, for a number of reasons, running true experiments within social work agency contexts are not always feasible or practical. So we talked in chapter 11 about randomly assigning participants to experimental and control groups, and we talk about the importance of doing this for our ability to achieve group equivalency or comparability between the two groups. One thing to keep in mind as we think about experimental designs, as well as quasi-experimental designs, is that at the end of the day, the researcher always wants to be able to say that it is the intervention itself that caused the outcome and not some other threat to internal validity, such as selection bias, okay? So the issue with selection bias is that if we don't properly deal with this, or if we don't properly minimize this threat to internal validity, then it could be said that, well, maybe it was the characteristics of the clients. Maybe there were some fundamental differences between the characteristics of those who were in the experimental group versus those who were in the control or comparison group that led to the outcome or the change in client outcomes. Maybe it wasn't the intervention itself. Okay, so we don't want that. We want to be able to say that it was indeed the intervention, which is why group equivalency is so important. We want to take whatever measures we possibly can to randomize, if at all possible, so that we can ensure that the groups that we are involving in our study are indeed equivalent. And in addition, we also want to try the best that we can to obtain a control group, which allows us to control for several of the threats to internal validity that we discussed in the last video. But as you can imagine, doing these things are not always possible. Okay, so randomizing clients into experimental and control groups, as well as even containing a control group in and of itself, may not always be feasible. Okay, and so we need some alternatives that we can work around in order to still be able to test the effectiveness of interventions, but maybe not in the same exact way as we would in a true experiment. So here is where we begin to talk about quasi-experimental designs. So these are alternative research designs that have less internal validity than the true randomized experiment, but can still provide support for causal inferences. So they're distinguished from true experiments primarily because they do not involve random assignment of participants into experimental and control groups. And also, some of the designs don't even require a control group, as we'll see momentarily when we get into our discussion about the various different types of quasi-experimental designs. So here's our case study, and again, I won't read through this, but I put it back before you once again, just so that you know that we're continuing to draw on this case scenario as we move forward in our discussion of research designs. So the first thing I would like to do as we talk about types of research, quasi-experimental research designs, is to discuss the basic logic of the quasi-experimental non-equivalent comparison group design. This is the quasi-experimental design that we will discuss that is the closest to the classic experimental research design that we discussed in the last video. Okay, so it's just one key feature that's missing from this design that makes it different from the classic experimental design. Okay, so we're going to discuss the basic logic underlying this particular design. So as you can see here, and this is the same exact diagram that showed up in the last video, but there's one key thing that is missing from this particular design that is present in the classic experimental design. And that is there's no random assignment. Okay, so we've already talked about this in previously, and I just want to reiterate this is that the non-equivalent comparison group design is exactly the same as the classic experimental design, except no random assignment. Okay, so again, we still have our intervention group and we still have our control group, but you will see that in quasi-experimental designs, instead of referring to the other group as the control group, we actually use a slightly different terminology where we refer to this particular group as the comparison group. Okay, so that's a slight difference. And then the also other slight difference is, of course, the lack of random assignment, but everything else essentially other than that is the same. Okay, so we have our intervention group, we have our comparison group, and we still place participants into, or clients rather, into either group. And we still measure whatever our dependent variable or client outcome of interest is. We measure it prior to the intervention. We measure this with the intervention group as well as the comparison group. And we expose only the intervention group to the treatment that is being tested. And we know here that for the comparison group, as I explained in the last video, as social workers, for ethical reasons, we typically don't withhold treatment. So we know that this no intervention here doesn't literally mean no intervention, right? We know that we still provide services even for the comparison group, even if it's just treatment as usual, right? And so then after the intervention is over, once the intervention is over, then we measure our dependent variable or our client outcome of interest once again post the intervention. Okay, so all of the steps here in the non-equivalent comparison group design in quasi-experiment land, right? So that's where we are now. This is exactly the same as the classic experimental design that we discussed in the last video, okay, with the exception of these couple of features that I've already mentioned, okay? So in terms of the steps in the non-equivalent comparison group design, we see that in step 1, we match subjects to the experimental group or the comparison group. So I put this here in blue just to make the distinction here from the classic experimental design. Okay, so because there's no randomization involved, as an alternative, we can use the method of matching. So remember in the last video, we talked about two methods for trying at least to achieve some sort of equivalency between groups. And so there were only two options. One was randomization and the other was matching. Okay, so since we don't use randomization in quasi-experimental designs, the other option in this case would be matching. Okay, and as I mentioned in the last video, we do the best that we can. Matching is not a perfect strategy because it's not possible to match on every single characteristic there's no way to know every single characteristic to match on. The best that we can do is look to the literature for guidance in terms of other characteristics that other researchers have matched on, and we can take their lead on that. And we can also use our own practice wisdom as well in terms of understanding what are some of the characteristics among clients. Is it age? Is it socioeconomic status? Is it level of education? Is it marital status? What are the characteristics among the clients that we serve that could potentially impact their outcomes, right? So we want to use the literature as much as we can as for guidance, and we also want to use our own practice wisdom to know what characteristics would be most important to match on. And we do the best that we can with that, understanding that there might still be some non-equivalency at the end of the day, right? But matching is better than nothing at all. Okay. In terms of step two, we administer the pretest to all subjects in both groups. And then in step three, we administer the intervention under investigation to the experimental group only. We administer the post-test to all subjects in both groups. And then in step five, we assess the outcome or the amount of change in the dependent variable from pre-test to post-test for each group separately. So again, all of the steps are the same as the classic experimental design with the exception of step one, okay? So going back to, or sort of reiterating what I've just said, in terms of terminology, we know that for the true experimental design, we refer to that other group as control group, and then within quasi-experimental designs, we refer to the other group as a comparison group. And then in terms of achieving group equivalency, we rely on the method of randomization for true experiments, and for quasi-experiments, we rely on matching. Okay, so now let's talk about types of quasi-experimental designs. So there are the three most common types of designs that are referred to in your text are, again, the non-equivalent comparison group design, the simple time series design, and the multiple time series design. So we've already talked a little bit about the non-equivalent comparison group design, but I'd like to provide a little bit more detail here than what I did previously. So we know that it is used when it is not possible to randomly assign. So we know that. We know that instead of using randomization, the researcher can use the process of matching to create groups. And in addition, as I've been saying, it is the exact same as the classic experimental pre-test, post-test control group design, except it lacks the R for random assignment. And we also know that the term comparison group is used instead of control group. So here's our notation for non-equivalent comparison group design. And notice here what's missing on the left-hand side is the R, right? So we know that the notation for the classic experimental design includes the R here to the left of the notation. And we notice now that with the non-equivalent comparison group design that R is missing. And that denotes that there's no randomization involved, okay? So here is a side-by-side comparison of each design, okay? So we see here our R in the classic experimental design, and we see that here there's no R, okay? Here is an example of drawing on our case scenario, going back to our example of our keys to competence in parenting intervention. And if we were to apply the non-equivalent comparison group design to the same intervention, the only difference here again would be that we would not be randomizing. into our intervention and comparison groups, and we would be using matching in order to place individuals into each group. Okay, so while the non-equivalent control group design is a pretty strong design in terms of controlling for threats to internal validity, we do have a major problem here still. And the problem is selection bias, right? So we know the importance of randomization for achieving group equivalency and thereby minimizing the threat of selection bias. But because randomization is not involved in the non-equivalent comparison group design, this introduces the threat of selection bias, right? Because it introduces this idea that there might be fundamental differences between the experimental and comparison group designs that could be the reason for the study results and not the intervention itself. Okay, so remember, going back to what I just said, that the researcher's goal is to always show in some way, shape, or form that it is the intervention itself that caused the outcome and not some other alternative explanation, including that of selection bias. Okay. So without the randomization involved, we have to deal with this issue or this threat of selection bias. So what I'm about to do is discuss two methods in your text that get at this issue of selection bias, and it provides sort of a strategy for dealing with this issue or for modifying this non-equivalent comparison group design in a way that addresses the issue of selection bias. Okay, so given the absence of randomization, a researcher would have to provide considerable evidence of the comparability between the experimental and comparison groups. Okay, so if we have this issue of selection bias at play, then that means that we as researchers have to provide some evidence that the two groups are indeed comparable or equivalent. Okay, two designs that can help offset some of the doubts about comparability and therefore strengthen the internal validity of the non-equivalent control group design is multiple pretest and switching replications. So as I talk about this, I don't want you to necessarily think of these two designs as different designs. I want you to think about them as modifications to the non-equivalent comparison group design. Okay, so it just takes the non-equivalent comparison group design and it modifies it in a way that helps to provide evidence for comparability or group equivalency. Okay, so that's how I want you to think about these two designs that I'm about to share with you. So here we have solving the problem. Okay, so just keep this in mind so that you don't get confused. These two methods that we're about to discuss are simply ways of solving the problem of selection bias by modifying the non-equivalent comparison group design. Okay, so the first way to modify this design in order to address the issue of selection bias involves administering the same pretest at different time points before the intervention begins. This allows for determining the extent to which one group may perform differently on the pretest than the other group. It also helps to provide evidence for any notable differences between the two groups prior to the start of the intervention. So here we see that in the classic non-equivalent comparison group design, we only have one pretest. Okay, one pretest prior to the intervention and one pretest post the intervention. But the modification here is to add on a pretest. Okay, so we have two pretests, one post-test in the multiple pretest design. And the reason why this is beneficial in terms of minimizing the threat to selection bias is that it allows us to look at or sort of establish a baseline that helps us to see whether there are any noticeable differences between the treatment group and the comparison group prior to the start of the intervention that we need to be aware of. Okay, so we see here that in this first example, for the first pretest at time point 1, we see that the two groups are pretty comparable. Okay, each group has a 10 on the pretest. However, when we get to the second observation, we see all of a sudden there's a dip in the score for the treatment group. Okay, where we see that the treatment group got a 6 on the pretest and the comparison group got a 10. So this is a red flag, okay, to suggest that maybe there are some different things going on with each group. Maybe the groups are not as comparable or equivalent as we thought they were. Okay, so this is a reason to pause, and really do some further assessment, in terms of where these potential differences, or what the source of these potential differences might be. Okay, so this is what we don't want in part A here. This is what we don't want. In part B, this is what we want, right? So we see that for the treatment group at time point 1, they received a 10 on their pretest, and then on time point 2, they also received a 10. And we see that the comparison group is the same, right? So this is evidence to suggest that perhaps the two groups are equivalent or comparable. Okay, so this is the best case scenario here. Okay, so this is the idea of multiple pretests, and this example here shows how implementing multiple pretests helps us to provide some evidence for group equivalency, or helps us to understand if there are any issues in equivalency that we need to be aware of. The other option here is called switching replications, and this involves administering the treatment to the comparison group after the first post-test. The goal is to replicate the results of the experimental group with the comparison group. If results are not replicated, then it is assumed that selection bias may be at play. Okay, so this also helps to minimize the threat of selection bias. So here we see that for the experimental group, in this first round here of testing, we provide the intervention to the intervention group first, okay? And then here, the comparison group, no intervention, okay? So we give the pretest, we expose the intervention group to the intervention, and the comparison group, no intervention. And then we switch it, okay, where here this time around, we do a pretest, and then the intervention group gets no intervention, and then we give the intervention to the comparison group instead. And the idea is that we want to replicate the same results that we got here for the intervention group. We want to replicate those same results with the comparison group as well. And if they receive the same results, then we can assume that there's no issue of selection bias. But if for some reason we cannot replicate the same results with the intervention group, then that means that selection bias could potentially be at play. So here's an example of this. So we see here that the treatment group at time point 1 received a 10 on the intervention, and then they were received a 10 on the pretest, and then they received the intervention, and then their post-test score was a 4. Okay. However, here, and we see here as well, same result, right? So when we administered the intervention to the comparison group, they had comparable results to the treatment group, okay? So this suggests that perhaps there's no selection bias at play, because we see here that the results were replicated, okay? So if we get this kind of result, then we're okay, okay? This is actually a good thing, because we were able to replicate or reproduce the same results among the treatment group as well as the comparison group. So in other words, when we say switching replications, we just mean that in one instance, we at one time point we expose the treatment group to the intervention, and then we switch the intervention over to the comparison group. Okay, and this is solely for the purpose of detecting any issues of selection bias. And then here is where we run into a problem. This is what we don't want, okay? So we see that what the results are for the treatment group, Okay, when we switch the replication over to the comparison group, then we see we get a different result. Okay, so this suggests that there could potentially be some selection bias or issues of comparability or equivalency at play because we were unable in this case to replicate the same results with the comparison group. Okay, so this suggests that there could potentially be some issue of selection bias at play here. Okay, so this is what we call switching replications. And again, these both multiple pretests as well as switching replications, these are both ways of correcting for the issue of selection bias that is inherent in the non-equivalent comparison group design. Okay, so just keep that in mind. Now let's talk about time series designs. So another commonly used set of quasi-experimental designs are called time series designs. These designs go beyond the use of multiple pre-tests by additionally including multiple post-tests. Okay, so the simple time series design is particularly feasible because it does not require the use of a comparison group. Okay, so we know that the realities of practice may not always provide you with the opportunity or present the opportunity to achieve a control group. There might be instances in which you may not necessarily be able to obtain a control group for some reason. And so this particular design does not require a control group, which might be particularly feasible for you and your purposes in practice. So this is the notation for this simple time series design. So we see here, as I just mentioned, that there are multiple pre-tests, okay? And then we have here the introduction of the intervention, which is our X. And then post the intervention, we have multiple post-tests. And this is pretty practical and feasible for you simply because there might be instances in which you might need to establish a baseline prior to introducing an intervention with your client. Having a baseline might be helpful to you in practice where you can kind of observe and monitor your client's progress prior to exposure to an intervention so that you can get a good idea of where they are in terms of the outcome you're targeting prior to exposing them to the intervention. And this could help to inform how you go about implementing the intervention. It can provide you with some useful data points so that which can then inform how you design and implement the intervention with this particular client or group of clients. And then we have multiple post tests, and this can also be useful in terms of follow-up, right? So rather than just stopping at one data point post intervention, you might want to know what the effect of the intervention has been on your client long term. Okay, so this would help with that as well. So here again, as I mentioned, these designs go beyond the use of multiple pre-tests by including the use of multiple post-tests. It doesn't require a comparison group design. And then also keeping in mind that each O represents a different observation point for measuring the dependent variable over time. So each one of these O's is a data point, essentially, right? Sometimes students ask the question, well, how many data points should you have, right? So there's no particular number of measurement points required. The more, the better. But it really all depends on what's most feasible for you in your practice. If you have a client that you don't see very often, then perhaps trying to collect 5 data points might not be feasible. 5 data points before and after pre and post intervention might not be feasible. Or if it's an emergency situation or it's something that's urgent, that in a situation where you need to implement the intervention sooner rather than later, then perhaps collecting 5 data points prior to the introduction of the intervention is not feasible for that reason as well. So it really just depends on your practice realities in terms of how many data points you decide to collect pre and post intervention. This is just an example of what a particular graph or chart might look like if you were actually graphing these data points, which could also provide a useful visual in terms of helping you to understand the trend in your data that you're collecting with a particular client. So in terms of, so here's your baseline. So in terms of all of the data points, here's your baseline data that you collect prior to treatment. And then this line here indicates the introduction of the intervention. The two most important data points here are the data points that you collect right before the intervention and the one right after the intervention. These two data points are going to be most instructive for you, but overall, having something like this, a graph like this, could be helpful regardless. But these are the two data points that you're probably going to want to pay the most attention to. And when we start talking about single systems designs, we'll be looking at some other graphs and charts that are similar to this. These data points here are post your intervention. Okay, so these are your follow-up data points here. But this is just an example of what this kind of data would look like graphically. And then here are your multiple, next is our multiple time series design. And so the major difference here with our multiple time series design is that we actually have a comparison group. Okay, so that's the major difference here between the simple time series and the multiple time series. They both involve several pre-tests and several post-tests, but the multiple time series adds on a control group to the equation here, so to speak. So this is a stronger design in comparison to the simple time series design. It has greater internal validity because it adds a time series analysis to the non-equivalent control group design. And I'll show a visual momentarily here of what I mean by this second bullet point here. In this design, both an experimental group and a comparison group are measured at multiple time points before and after the intervention. So what I mean by the fact that it adds on a time series analysis to the non-equivalent comparison group design is that here with the non-equivalent comparison group design, we just have one data point before and one data point after, but also still the comparison group, right? So the difference here is that it adds on this time series analysis in terms of adding on these multiple time points. So this is almost, the multiple time series design is almost like an extension of the non-equivalent comparison group design. And it extends this design by adding on these multiple time points, pre-intervention and post-intervention. Here's another example of what a multiple time series design could look like graphically, where we would have, let's just say hypothetically that this is our chart for our intervention group. And then this would be our chart for our comparison group. And we can compare the trend line and the data points between each group. Here's the chart that I provided in the last lecture, and I also wanted to provide the same chart for our discussion on quasi-experimental designs. So here are the notations here, and you can review these and study these in your own time of studying. I included a bit more explanation here, just because when it comes to whether or not some of these threats are controlled for, or how they play themselves out in each design, it really does depend, right? It's one of those things where it's kind of like, well, it depends, right? It depends on this or it depends on that. So I try to provide a little bit more explanation here, just because it's not as cut and dry with quasi-experimental designs. So there is a bit more explanation here in these tables in terms of whether or not each of these threats are controlled for, and why they may or may not be, okay, within each design. So now I'd like to talk about some of the pitfalls in carrying out experiments and quasi-experiments in social work agencies. So a couple of the pitfalls, one is related to fidelity to the intervention. And what we mean by fidelity is the extent to which the intervention is delivered to clients as intended. Okay, so this really has to do with any time, I say this often to students that carrying out an intervention, especially within a social work agency context, is very much a human endeavor. And anytime we are involving humans in the research process, there's always room for error, okay, and mishaps and things of that nature. And so Whenever we're delivering an intervention, we always want to be concerned with the extent to which individuals are following directions, okay, and doing things in the way that they were intended. So this has to do with fidelity to the intervention, and there are all kinds of reasons why this may not happen in an agency context. So this is definitely a pitfall that we want to be aware of. In addition, contamination of the control condition is another potential pitfall. Um, and this has to do with when the intervention group and the control group become or interact with each other. Okay, so even if the intervention is delivered as intended, the control group can still be contaminated if the control condition can still be contaminated if the control group and the experimental group interact with each other. So ideally, we would want to perhaps recruit our experimental or intervention group within our agency context, and then perhaps obtain our control group from another agency, okay, if at all possible, because what we don't want to happen is for our control group and our intervention group or experimental group to interact with each other. We want to try to avoid contamination if at all possible. And then we have resistance to the case assignment protocol. So here again, because we have humans involved, there are times in which some practitioners may resist assigning clients to treatment conditions on the basis of the research protocol, and they prefer to use their own professional judgment because they feel that they know what is best for their client. So it might be difficult at times to get buy-in from practitioners. Some might believe that their client should be in the experimental group, or that their client should be in the control group for whatever reason. So there might be some resistance involved when it comes to adhering to instructions and directions around the way in which the intervention should be implemented. Okay, so this could also be another pitfall. And then also going back to what I just mentioned in terms of recruitment, whenever we're having to rely on referrals from outside agencies, because if we're going to go to another agency to obtain our control group, then that means that we have to rely on an external agency in order to help us to recruit clients into our control group, or maybe even at times into our experimental group. And so anytime that we're relying on referrals, especially for agencies that are external to our own, then we run into this issue of client recruitment as well as retention, because we have the issue of attrition that we always have to be worried about. And so uh, as quite naturally, we have less control over what's happening on the outside of our agency, and we have more control over what's happening in our agency. So trying to work with external agencies in order to recruit as well as retain clients in order to prevent issues of attrition can be challenging. And so that's something that we also have to keep in mind in terms of potential pitfalls. In terms of mechanisms for avoiding pitfalls, one of the things we want to do is engage agency staff members in the design of the research study and enlist their support from the beginning, which could help to prevent the issue of resistance. Okay, if folks are involved, typically they're more likely to buy in to what it is that we're trying to do and less likely to resist. We also want to build into the study mechanisms in which the research team members on site at the agency, in which we have research team members on site at the agency to interact with staff members and monitor implementation on an ongoing basis. So in other words, when we have researchers involved, we don't want them to operate sort of peripherally from the agency. We want the researchers to be involved with the staff that are responsible for implementing the intervention. We want them to be there and monitoring the implementation on site on an ongoing basis, and this could help to promote fidelity to the intervention. We also want to locate experimental and control conditions in separate buildings or agencies, as I mentioned, which can help to avoid contamination. And then we also want to, if at all possible, develop a treatment manual, which can help to promote fidelity to the intervention. So if we're able to provide folks with a clear set of instructions on what to do and when to do it, how to do it, it doesn't necessarily mean that this is foolproof in terms of the promotion of fidelity, but it certainly can help, right? So if research staff are not able to be on site every day, right? And so as long as folks have something they can go back to that provides a clear set of instructions, this can certainly help to alleviate issues of fidelity. And then your text also talks about some qualitative techniques for alleviating pitfalls. And I've just listed a couple here, but you can also see page 289 in your textbook for additional examples. So a couple of the qualitative techniques, I'll just talk about a couple of them and the rest you can study on your own. But a couple of them, one thing we can do in terms of promoting or assessing fidelity is we can record practitioner client sessions. We can record those sessions either via video or audio, and this can help us to assess the extent to which the practitioner is remaining true to the fidelity of the intervention. We can also have informal conversational interviews with agency staff, and this can also help to bring out any issues with compliance that may be at play. And we can also use focus groups where we can document the process of implementation of the intervention and identify any problems. And then we can also use ethnographic shadowing or following practitioners in their daily activities. And this could also help us to learn about how practitioners are actually implementing the intervention and the extent to which it is consistent with the treatment manual. And then finally, here are, in this next section, are questions that can be utilized to critique quasi-experimental research designs. And the one thing I'd like to point out is that the questions are slightly different depending on the type of design. So here's the set of critique questions that you would utilize for the non-equivalent comparison group design. And as you can see, most of the questions really get at this issue of selection bias because that's one of the biggest issues within that design. And then we have critique questions for the time series design. So these questions are very specific to this design. And a couple of the issues that are most present in time series designs have to do with history maturation as well as selection bias. History of maturation, particularly simply because we're talking about the collection or observation of data points over time. So we know that anytime we're extending our intervention over time, we always have to be concerned about the issue of history as well as maturation. So here's a set of, these set of questions have to do with time series design specifically. And then I've also included and slightly modified, these questions were included in the last video as well, but I've slightly modified some of them to fit quasi-experimental designs as well, or to include this design as well in these set of questions. But these are more general questions that can apply to either experimental or quasi-experimental designs. So these questions are included on this slide as well as this slide. Okay, so you can review these as you study as well as you write your second article critique. And then here's the exercise for the week. And you can complete this or not, depending on if you'd like some further application of concepts. And here's my contact information as always. Please feel free to reach out to me anytime with questions. I hope this was helpful, and I look forward to seeing you in the next class.